Maximum minimum finding numbers. The sum of two non-negative numbers is 20. Find the numbers if one number plus the square root of the other is as large as possible or as small as possible. So what we are given is that two numbers sum is 20. So let the numbers be x and y. In that case, x plus y equals to 20. Now we can write one number in terms of another. So we can write y equals to 20 minus x. So these are the two numbers. Find the numbers if one number plus square root of the other is as large as possible. So we are finding a sum of one number plus square root of another. So one number is, let us say, x plus square root of y. And we want to maximize it or minimize it. This is the question, right? So from this equation, we can write y in terms of x. Then we'll have equation in one variable. So we get x plus square root of 20 minus x. Now to maximize it or to minimize it, we have to find derivative of this function with respect to s. So ds over dx is equals to 1 plus derivative of this is half 20 minus x to the power of minus half, so I'll write it in the denominator, 20 minus x, and derivative of inside function, which is minus 1. So that is my derivative. Now I can write it in a simpler form, kind of. I will just, or we can leave it like this and then do cross multiplication. But in any case, let me write like this now. Minus and 2 square root 20 minus x. So that becomes our function. Now, you will note here that y is equals to 20 minus x. It says sum of two non-negative numbers is 20. So that means there is a domain of x. If x is 20, then 20 minus 20 is 0. But if x is 21, then what happens? Y becomes negative. Therefore, we have a restriction on x. So we should write that x has a restriction and x should be greater than or equal to 0 but less than or equals to 20. Do you understand? Because if it is more than 20, then y becomes negative. So that is our restricted domain. So these values are the boundary conditions for which we should check the value of our function also. Correct? That's the whole idea. Now this will give us a critical number. And what is a critical number? Critical number is the number which will give us a 0 for the derivative or undefined value for derivative. So those are the critical numbers. So in this particular case, ds over dx can be undefined at x equals to 20. So that is a critical number for our function. It is undefined for x equals to 20, right? So in this particular case, we do have a critical number, and that is when x is equals to 20. Now let's write down this equation in the form of ds over dx equals to, we'll take common denominator. So we get 2 square root of 20 minus x minus 1 over 2 square root 20 minus x. Right. Now let's find critical number by equating ds over dx as equals to 0. So that is to find critical number. That means numerator should be equals to 0. Now let's equate numerator to 0. That is 2 square root 20 minus x minus 1 equals to 0. And that gives us a value. We'll solve it. We'll take 1 this side. So we get square root of 20 minus x is equals to half, and we can square both sides, which is 20 minus x equals to 1 over 4 when we square, and then x is equals to, taking x here, 20 minus 1 over 4. That gives us a value 80 minus 1, which is 79, right? So we have 79 over 4 as the value of x. Correct? Now, what is y when x is 79 over 4? Y will be equals to 20 minus x, which is 20 minus 79 over 4. And that is 80 minus 79 over 4, or 80 minus 79 is 1 over 4. So these are the two critical numbers for us. I mean, the critical number is x is equal to 79 over 4. That gives us y 1 over 4. Now, in our function, which is x is greater than equal to 0 and less than equals to 20. So to find maximum minimum, we have to find the values of sum, which is sum is equals to x plus square root of 5 for critical number and for the boundary conditions. That is x equals to 0 and x equals to 20. Correct? Now, if x is 0, then y is 20. If x is 20, y is 0. Do you understand? So we'll check sum for all values. So let me write sum when x equals to 0. Let me write like this. S equals to 0. Then what is this sum equals to? Then if I put x equals to 0 here, I get 0 plus square root of 20, right? So that is the value for s equals to 0. How about s equals to 20, the other extreme? X equals to 20 gives me a value which is 20 plus square root of 20, right? 20 and square root of x equals 20, this term becomes 0, just 20. And how about s equals to 79 over 4? When we write 79 over 4, then we get here 79 over 4 plus square root of 20 minus 79 over 4. So this is the value to be calculated. So we can use calculator to calculate. It is 4 times 20 is 80. 80 minus 4, which is square root 1 over 5, which we have already 1 over 4, which we have already calculated for y. Correct? We could have substituted the same value here. So square root of 1 over 4 will be half. So it is 79 over 4 plus half. Let me write 79 over 4 plus half. And that gives us, so this is like 2 over 4. Correct? So 2 plus 79 is 81. So it gives me a value of 81 over 4. Now 81 over 4 is when you divide 20 and then 0.25. So clearly 20.25 is more than 20. Therefore, this is the maximum value. Do you understand? Let me push the paper a bit so that you can see it very clearly. So we have a maximum here for x equals to 79 over 4, and the maximum sum will be this much. And the minimum here is this value, square root of 20, right? That is the minimum value. So we have both the answers right there. So we can write on our answer that minimum is when x equals to 0 and y equals to 20. And maximum is when x equals to 79 over 4 and y is equals to 1 over 4, right? So these values will give us maximum. I hope you appreciate how we have applied boundary conditions to solve this equation, right? So this is very important criteria. Otherwise, it would have been difficult for us to get both the values, as large as possible and as small as possible. So boundary conditions and the critical number help you to find maximum and minimum whenever we have a function which is restricted, like the one which we had. X is actually between 0 to 20, so you need to identify it right from the very beginning to get the correct solution. I hope you appreciate it. Thank you and all the best.